Uh, Welcome, class. Just want to go over scientific notation as a preview to get ready for class we're going to start next week. Okay, so the question is, what is scientific notation? Okay, scientific notation is a way to represent, okay, large and small numbers. Okay, so people are like, okay, why don't I just write the numbers itself and then make it that easier? No, well, sometimes with scientific notation, it basically gives you an opportunity to write huge, really large numbers and really small numbers, and people can represent and understand them. So, like if you have like say old trillions of dollars in the bank, okay, you don't want to just say I got trillions of dollars. Maybe you could be wrong. You could have zillions of dollars, but we don't really know what that how many zeros are in trillion, how many zeros are in zillion, but we do know that that's a lot of money. So using scientific notation can give us an opportunity to write that. And what if we wanted to add more money to that, like multiplication? We could use scientific notation to help you multiply those two large numbers together and then be able to get a big answer. Same thing in terms of the decimal place. So, like I said, if you're a scientist and you're trying to uh, measure out a certain amount of medicine to put in the beaker or something like that, you can use scientific notation to know exactly how much that measurement is, especially if it's a really small amount. Okay, so that's the reason why some people use it again, and the reason why we teach it is because we want you guys to get working on moving the decimal point left and right, and also be able to tell exactly if I multiply by 10, how much actually the value goes up by or it goes down by. All right, so let me show you how this works. Okay, so first thing you want to do in this type of problem with scientific notation is you want to find the first two numbers in the series, okay, in the number sequence. Okay, so the first two numbers is 4 and 6. So I'm going to put a decimal point between there. Okay, that's the first thing I'm going to do. Next thing I'm going to do is count how many spaces I go from the right, from the left to the right after the decimal place. So I have one space right here, one space right here is 2, 3, 4, 5, 6. Okay, I have 6 spaces. Okay, so how I would write this as scientific notation would be 4.679. Okay, and I would times that by 10 to the power of 6. Okay, so again, I'll say it again. What I did is I first two numbers in the series, I looked and I put a decimal point between the first two numbers, and then I counted how many spaces that decimal point would have to move to make this get all the way to here, and that's where I get my 10 to the power of 6. Okay, so that would be the scientific notation of this situation. Okay, so let me show you the other way. Okay, so it's the same. Now, when we have a smaller number, we have to look at the first numbers in the series. Okay, first numbers starting in the series. So again, same like this. We look for the first two numbers. This is the first numbers. We start at 0, going all the way through, and here's the 4 and 6 are the first two numbers. I want to put a decimal point right here between 4 and 6. Now I'm going to do the same thing, but I'm going to go opposite way. So I'm going to go 1, 2, 3, 4, 4 spaces over to the left to make this a smaller number. So then I would just write it like this. I would write 4, same thing, 4.679. That's a terrible 9, man. Jeez. Let me fix this 9. Sorry, guys. Jeez. All right. 9 there. Okay. Then we want to multiply that by, okay, and then we have 10, and then I counted 4 times over, okay? So instead of, again, when it's negative, when it's smaller, we're going to do -4, okay? So here's the difference. if we have a large number and we're trying to make it a scientific notation, we start from the left. The first two numbers, we put a decimal point. We count how many spaces over, and then we make a positive exponent. If we have a negative one, we look to the first two numbers that are whole numbers, okay, like the 4 and 6, and then we count how many spaces over to the left, and then we write a negative number to represent the small portion, okay? So that's how it would work in terms of scientific notation. All right, so these are condensing them, making them smaller as well. So let me show you how to make them, how to expand them and make them bigger. So first we have 3 times 10 to the third power, okay? So what do we know about 10 to the third power? That's basically 10, okay, 10 times 10 times 10, okay, and that equals 1,000. So if you think about it, basically what we're doing is taking 3 times 1,000, which equals 3,000. Okay? But like we said before, if it's a positive exponent, we're going to stop at that point of 3 after 3, and then we're going to move the decimal place 3 spaces to the left, to the right. So think about it. Here's a decimal point right here, 1, 2, 3, and we got the same answer of 3,000. Okay? So again, moving the decimal place is all you're doing at this point. So let's look at the next one here. We have basically 7 times 10 to the negative 2. So we said negative 2 is going to make the value smaller. So if we make a point in front of the 7, okay, we're going to add 2 zeros. So again, we're going to move the value 2 zeros to the left. So it would be 0, 0, 7, and it would be a point right here. Okay, and that would be the value of it. So if you want to think about it, like, well, how does that hold true? Okay, so what do we know about negative exponents? How do we turn a negative exponent into a positive exponent? This is why we do scientific notation second. Okay, yes, we should know that. Okay, so basically we put it over 1. So it would be 1 over 10 squared times 7. Okay, so if you think about it, we basically did 7 over 100. If you do the math out, it's actually going to equal this number right here. Okay, so that's how we would do the situation. So again, negative exponent, okay, we're making the value smaller. I'm just going to get over here. Okay, we're making the value smaller. Okay, positive exponent, we're making the value larger. Okay, and that's how we do it. Okay, is basically using the values and trying to put the information together like that and helping us out. So again, like I said, negative positive exponent 10 to the power of 3 times 3 is 3 spaces over to the right. Then we have negative. When we have a negative 2, that means we're going left after the before the decimal point for the number, and we're going left that many spaces. Okay. Hopefully you get this. Again, if you don't, it's okay. Just try a couple problems, and then we'll catch up with you next week. Bye now.